Okay, so let's get going with some maths. So what I want to do today is I want to start with kind of our basic definitions that are involved. So the three trig graphs the basic trig graphs that you need to know about are y equals sine x, y equals cos x, and y equals tan x. And in their most basic form, you need to know the shapes and you need to know various characteristics about those graphs. And so we're going to talk about what those characteristics are today. And I thought a nice way to do that before we kind of get into those details is we'd have a bit of fun quizzing and we'd see kind of what we know and what we don't know about this. So I've just got some fun multiple choice questions to start us off. So let's start with that. So if you look at this graph, I want you to take a moment and look at it. And then I want you to think about which of the four graphs do you think is shown over here? Don't vote yet. I want you just to think about it. And then what I want to do then is I want you then to vote in the chat. What trig graph is this graph? And you can vote in the chat with A, B, C, or D. I'm just going to hit mute all. Who did I unmute? Or did I mute? Okay, so now if you feel a bit stuck, I do want you to raise your hand and ask a question. So there's a blue graph here, and I want you to identify, is it A, B, C, or D? Otherwise, I'd love a question from the students of the class. Lebel, can you hear me okay?
Yes, I can hear you, Mr. S.
Okay, perfect. Give me a thumbs up if you're still thinking. I just want to see the students can see the screen properly and everything. Thumbs up if you can see the screen and you're still deciding. And then once you've decided, you can vote. So once you have decided what graph you think it is, then put your vote in the chat. Remember, there's only three, well, there's four choices here. So Bonolo has voted. Do you agree or disagree with Bonolo? I'll give you a little hint. So if you look at this graph, when you're at 0, this graph seems to be at 1. So when 0 is on the x-axis, the y value is 1. Now, that might help you decide, even if you use your calculator, which trig function has a value of 1 when is the sine of 0, 1? Is the cos of 0, 1? Is the tan of 0, 1? And that might tell you something about this graph because okay, so Teddy is also given us a vote. Who else would like to? I want to see a few more students commit. Even if you get it wrong, I don't mind. And then I know from the ratios kind of what to explain. And I'm wondering if I shouldn't try and bring up my calculator too. I'll bring that up in my later part of the lesson. Okay, so I'm still waiting for Muji, Owami, Rosaria. Whatever you think it is, pop in the chat. Zanele, Nolotando, Sipasicle. Okay, the votes are in. Sipasicle, would you mind unmuting and telling me how you knew it was the one that you said? What were you looking for? What key idea were you looking for?
Hi, sir.
Hey, how did you know which one it was?
The y-axis is 0, and then the x-axis is 0, and then the 1, I
Yes.
think it's the y-axis.
Yeah. So you look for that one. All right. Perfect. Thanks, Sipasile. So the correct answer is B. All right. So the correct answer is B. And so just as we start today, if you imagine a trig graph and you imagine it marked out in increments, right? So let's say it's 90, 180, 270, 360. We'll make that 1, make that -1. The cos graph, the cos of 0, if you put in your calculator, you'll see is 1. And it has the shape which goes like this. So the first one is cos, and we're going to have a few more votes, and then based on what I see in the votes, I will explain some of the shapes to you. Okay, give me a thumbs up if you're happy to move on to the next question. Have another go. Give me some thumbs up, or give me a question if you want me to explain something more about the cos graph. The main idea of this initial stage is just to identify the graphs. Okay. Okay, let's not do that one. Let's do this one. Which graph is this one? So you'll see that there's a green line, and I want to know a bit more about these graphs also. Like there seems to be dotted lines on these graphs. So take a moment, think about your answer, and then pop it in the chat. Which graph do you think this is? Okay, so I see quite a few answers coming through in the chat. And I think I agree with you. T, can you tell me, so I agree with the answers that are coming through. The correct answer is C. So it's y equals tan theta. I'd love to know what these dotted lines are. So, if Teddy or Zanele can tell me, there seems to be dotted lines at 90, at 270. What is that all about? Could you just come on and tell me if you know what those dotted lines are?
So those are the asymptotes.
Asymptotes.
So the graph can never touch those lines.
You are winning at life. They are indeed asymptotes, and the asymptotes are every 180 degrees, it seems like, in the tan graph. And that's because the tan graph has a period of 180 degrees. It repeats itself every 180. Now, that is awesome. I do want to ask you guys, though, in this graph, when I say the period of the graph, it's how long it takes to go basically a full cycle. And I want to know, what is the period of the cos graph in this question 1? While we're doing this, we're just getting to know what's the period of this graph. I'm kind of jumping around a little bit. Okay, so the period of the graph normally refers to the horizontal part. So when we look at the graph, we look at how long does it take before the graph has gone all the way back to where it started. And if you look at that dot there, it went down, down, up, up, and then it's back to where it started. So that's called a full cycle, or one full period. And I want to know, how many degrees does it cover? So in this case, what you see, what is this distance over here? It's 360 degrees. And so the period of the sine on the cos graph is 360, and its shape also looks a bit different, whereas the period of the tan graph is 180. So that's one of the first ideas today I want to take note of. Okay. Are there any questions about the tan graph? I'll give you a moment, and then we're going to move on. Okay. I want to know which of these three, or A, B, C, or D. So there's a curve. This is a trig function. And I want to know, is it A, B, C, or D? Come on, ladies and gentlemen. I'm sure you have an opinion. Doesn't have to be right. I just ask that you give your opinion. Aha, Teddy has locked in his vote. I'm looking for votes from Sipasihle, Owami, Muji, Lesejo, Zanele, Nolotando. I want to see you get some skin in the game here. You need to put your vote in here. Still a few more students. Okay, awesome. So you are quite right that the equation of this graph is A, y equals sine x. Now, what I want to ask you now, in addition to this, is what is the period of the sine graph? What is the period of the sine graph? And I want you to tell me that in the chat if you know it, or maybe you can work it out based on what I explained in the previous question. What's the period of the sine graph? So I see lots of you have got the correct answer for A, and Teddy is knocking it out the park. It is 360 degrees. So just to look at that journey, you can imagine it goes 0 to 90, then 90 to 180, to 270, to 360, and that is one full period of the graph. Now, you can imagine that there's another full period over here, and if you wanted to, you could go from 360 to 720, and you get another full period. Now, in terms of the reason they call these periodic functions is because they repeat themselves. That's why trig functions are called periodic. Okay, now, new question. I want to know, what is the range of the sine graph that you've just seen here? Now, that's another characteristic. And I would love someone to come online. I want to hear some lovely human voices. And I want to know, what is the range of the sine graph?
Let us know what you think, guys.
I know you want to, Benolo. I know you want to. I can feel your fingers itching. You're thinking, oh, why does it have to be me? And I know you want to. What's the range? What does range got to do with? There we go. So just pop your hand up. Or Rosario, I want to know, what do you think the range of the sine graph is? So the range has to do with how high or how low a graph goes. So basically, what is the range between which it occurs? It's like, how high or how low does it go? Okay, so the range is, you're probably thinking of the amplitude, Manolo. So it goes between, the range is between -1 and 1. Can you see the highest place it gets to is 1? So this coordinate here would be 90, and that would be in line with 1. So that's the highest it gets to. And over here at 270, it gets down to -1. So the range is between -1 and 1. Now, the amplitude, which we're going to come to later, is how high it goes or low it goes from the position of rest. And so in this case, for the sine graph, the amplitude is 1. It goes only 1 unit up, or it goes 1 unit down. And we call that the amplitude. So that's 1. Okay, so what have we learned so far? The basic shapes of 3 of the trig graphs. And we need to know about these things called the period of the graph, the range, and the amplitude. Now, another word that's going to come up as we draw these graphs later today is what's called the step size. And the step size we get by dividing up the period into sections. And for sine and cos, you break up the period into 4 sections. For the tan graph, you divide it up into two sections. But let's have another multiple choice question here. So I want to know from the people of the room, what effect does the transformation of sine x plus 3 have on the graph of y equals sine x? So we're comparing, they're saying, how is this one different to the one over there? And what happens to it when it gets transformed? And you have a choice of A, B, C, or D. Okay, so basically what happens is that the +3 shifts the whole graph up. So normally your sine graph would be between 1 and -1. But because of the +3, if you go up from, if -1 was the bottom, it's now going to go up and start all the way up here and then go all the way up to 4, 2, 3, 4 up here. And that's going to be in between. So the whole graph has really just moved from being between here to being between here. And it's gone up by 3 units. And so the correct answer would be +3. Awesome. Okay, that was pretty good. Next question. What effect does the transformation y equals minus cos x have on the graph? So in this case, it's the normal cos graph. And we saw it earlier in the lesson. It used to go like that, starting at 1 and then going down. What do you think this does? So that's what the normal cos graph looks like. What does the minus do? Think about this for a second. So this minus will change the sign in front of the y. So instead of starting up here, it would be down here. And the next one would also be here. So the graph would start to look a bit like that. And you're quite correct. You guys are winning at life. So basically, if you look at it, it's reflected it over the x-axis. Now that was a bit tricky. So I just want to pause and ask, are there any questions about that? Or give me a thumbs up if you understand kind of what that transformation does. Because I thought that was a bit tricky. So the blue one is the transformed one. Just give me a thumbs up if you are you with me? Okay. Now, I want to be Mr. Teacher Man and throw a curveball at you. I want you to think about what would the graph of y equals 2 cos x look like? So I want you to take a moment and think, okay, so far we've got the green one. The green one is y equals cos x. The blue one is the shifted one or the changed one. I'd like to know, and I'd like you to take a moment. I'm going to give you a minute, and I want you to try and draw the graph of y equals 2 cos x on a on a kind of sort of axes here. And once you've completed that, I want you to say done in the chat. So see if you can draw the graph of y equals 2 cos x. And while you do that, I'm just going to set my axes up a bit better so you can see what's going on. 180, 270, 360. So take a moment. And what I would do is I would mark off the markings of 90, 180, 270, 360 on the horizontal. And then I'd mark off 1, 2, -1, -2. And then once you're done drawing the graph, I want you to let me know. So grab some water. While we're waiting for people to draw, I'd love somebody to put in the chat, what type of transformation does this 2, what does this change, or what word is related to this 2? Or maybe you can even come on and just tell me a little bit of what you think the 2 is doing. What is it causing to happen? What do you think, Zanele? What do you think the 2 is causing? Aha. Teddy, I like what you're saying. Teddy's saying start at 2. Now, the fancy word for what is happening is called an amplitude change. And you're quite right. You start at 2, but it's almost like the graph is being stretched upwards. So just put done in the chat when you are done drawing, and then I'm going to draw the graph for you, or rather with you. Oh. Can you still see my OneNote?
Yes, we can still see it, Mr. Ace.
I was just trying to bring my calculator up, just maybe give us some help, but I don't know if it's going to be cooperative today. Okay. I want to see in the chat, are we done? Can I move ahead and draw the graph for you? So you should be starting, like Teddy was saying, you should be starting over here. And when you draw a cos graph, what I tend to think about doing is saying, okay, the period is 360, and there's going to be 4 chunks. And so 360 divided by 4 is 90. And we call that the step size. And so now when I draw my graph, I'm going to draw it in 90-degree steps. Okay, so the first step is to go from 2 down to 90. Then the next step is to go from 90. Oh, something just changed. From 90 down to 180, then 180 up to 270, and then all the way up to 2. And what you see is that the 2 is vertically stretching the graph up, or we say it's an amplitude change. Okay, so that is the shift there. All right, now I want to know for this red graph here, and then we're going to have a break for our time. I want to know what is the range of the red graph, or the y equals 2 cos x. Can you tell me in the chat, what is the range of y equals 2 cos x? And then we're going to take a break. Yeah, you can see the range here. The range goes all the way from here up to here. And so we would say that the range is from -2 up to 2. Yes, Sipasihle, you are winning at life. Now for bonus points, what is the amplitude? Yes, Bonolo. Yes, yes, yes. My people are learning. I love it. Now, the amplitude is basically how far it goes above or below the position of rest, and it can never be negative. So what do you think the amplitude is here? Yeah, the amplitude is 2. Perfect. Well done, everyone. Well done. Okay.
Very
now,
nice work, guys.
we have been working hard, and you know what's coming next? My favorite part of the lesson. It is time for us, okay, to stretch it out. So turn on your cameras. I want to see your lovely faces and join me in a fantastic stretch. I know we're having to push extra hard today, but do it. So join me in stretching it out.
Please join us in the stretch, guys. You know we love to see your faces.
Yes.
Don't be shy.
Promise we don't fight.
It's just a few of us today, just the 12 of us. Come on.
I want to see you guys. Just quickly, just a quick hello. Hi, Bonolo.
Hi, Bonolo.
Oh, it's so nice to see you, Bonolo. You look such a happy person.
Come on, guys. Anybody out there? Don't let us have all the fun.
Oh, that is good.
I hope you are not missing out on this, guys. Oh, we saw Nolitando for like a second.
There we go, Rosaria.
Rosaria.
Hello. Okay. So let us now go to a brain break. So here is my brain break for today. And my tip for you is, remember, once upon a time in a land far, far away, we did something called Venn diagrams. And they may be your friend on this brain break question. So go ahead and let's see if you can tell me how many students are bare feet. Okay. So we have, I'll give you a hint. There are the people who are wearing socks. And there are people who are wearing shoes. Now, where are the people that are barefoot is the question. And who are the people that wear socks and shoes? I'll give you some time to think about this. Aha, I see some good. So there are 12 kids in the classroom. 6 kids are wearing socks. Now they would be inside the green circle. 4 are wearing shoes. 3 kids are wearing both. So from what I remember, I learned about in probability that must be 3. And then 6 kids are wearing socks, which means this must be 3, because that includes both. This must be 1. And so then in total, how many students were there? There were 12 kids in a classroom. So I go 12 minus 3 minus 3 minus 1, and my final answer is 5. So there are 5 students that are barefoot.
Well done, everyone.
I thought that was quite a cool one. Give me a thumbs up or a like if you like that one, or because I was like, oh, this is such a nice combo of something we've done before, but also a little bit interesting.
Or you can give us a smiley face. Super like this.
Yeah.
Yes.
I thought so too. I was like, I do a lot of brain breaks. I was like, I like this one.
Yes. It was a good one.
Okay, cool. So we were on this journey. Now, before we continue with our trig graphs learning, if there's anything in particular you would like me to focus on in the second half of the lesson, please do put that in the chat. Otherwise, I'm going to carry on doing what I'm doing. But I just want to know if there's anything in particular. Let me go. Let's go to this one. So, according to the graph below, what is the value of the cos of minus 60? So I'm giving you the cos graph. So this is the graph of y equals cos x. And I want to know, what is the value of the cos of minus 60? How would I find out what that is? Where would I look? So which of the 4 options is going to be correct? I'm going to say for sure that it can't be B and it can't be D. Now, I've got a choice. I might be a little bit... No, one of the things I'm thinking, I'd like to know what root 3 over 2 is as a decimal. So I know I meant to just use the graph, but if I go into my calculator, oh, this calculator is not happy with me. Root 3 divided by 2, that in decimal land is 0.86, which is going to be very, very high. So this is, I can check my answer by checking my calculator, cos of minus 60, just to make sure, and it is a half. So that is correct. No, you guys did pretty well there. Any questions or comments? Okay, all good. Then for this one, what is the value of the cos of 120? So same graph, but they want you to try and work out what is the value of the cos of 120 according to this graph. To find where is 120 and what value is that going to give us? It's probably going to be somewhere around here. And if you look at that, what's that in line with? So I think I'm going to cross out A and I'm going to cross out D. And the reason is, if this is 120 on the x-axis and I look at the y value I'm getting must be negative. So the only ones that are possible, or actually, that's also positive. So the only value that could be right would be value C. Because when I look at the value that's involved, the point that I'm looking at is here, its y value is going to be negative. It's going to be a negative a half. So the answer would be C. Just give me a thumbs up if you understand how I know it had to be a negative by looking at my graph. Just want to make sure that you are with me on that. Do you understand why it had to be negative? Okay. Up or down? Ooh. Okay, all right. Fantastic. Okay, we're going to leave out those two. Okay, so if I show you the basic trig graphs, that's what they look like. And today in the lesson, we've spoken about a couple of things. And what I want to do is I want to sort of do in the last part of the lesson, draw some different types of graphs. So the basic graph, we said already, for sine, the period is 360. With cos, period is 360. With tan, period is 180. Now, when we draw graphs, we also tend to divide them up into what's called the step size. And so when I'm drawing a sine graph, the step size is just going to be whatever the period is divided by 4. So in this case, it would be 90. For the cos graph, the step size would also be 90. For the tan graph, the step size is going to be 90 because it's only divided up into 2 equal halves. So this is going to be quite useful to bear in mind as we draw these graphs. The other thing is that the basic sine graph, cos graph, all have amplitudes of 1. So that has an amplitude of 1. It only goes 1 above and 1 below where the position of rest. And the same with this. However, we can sometimes change things in the graph. And when we change things about the graph, so earlier on today, what we did was we drew the graph of y equals 2 sine x. And that graph looked very different to the one that's here. The one that's here goes up to 1, whereas y equals 2 sine x, it starts here and goes all the way up to 2, then down, then it will go down to -2, and then up again like that. And so that is called a amplitude change. It goes higher and lower than before. Okay, let's actually do a question where we change something. So here are, so actually today we're not going to draw, we're just going to look at this. these are 4 different trig graphs. And what I notice is in the first one, there is one change. There's a change there. In the second one, there is 2 changes. There's a thing there and there's a thing there. In the third one, there's a change there. And then in the fourth one, there is a change here and a change here. Before we start answering this question, I want to know, what does this number in front of the angle do? Does anybody know what that affects or what that changes? Who can give me a hint in the chat there? What does that number in front of the angle change? So in this particular case, this doesn't change the amplitude. What the number in front of the angle changes is, yes, Teddy said, how many times will the graph fit in 360? It changes the period of the graph. So the number in front of the angle will change the period of the graph. So, for example, in y equals -3 sine 2 theta, the normal period of the graph, of the sine graph, is 360. But because there's a 2 in front, the new period of the graph will be 360 divided by 2. Or we would say the period is 180. So the number in front changes the amplitude. The number in front of the angle changes the period of the graph. Okay, let us do the first row. So I'll get rid of this for now. And I want to know, in the very first one, y equals a half sine theta. I want to know what A, B, and C are. Put your answers in the chat. Let's see what you get. What is the period of the first one? What is the amplitude? What is the range? I'll make that 1, that -1. What do you think the period of this graph? Has anything changed the period of the graph? So I'm actually going to draw the graph for you. Let's go. So I have drawn the graph. Oh, that's too thick. Then this would be using what I've shown you. I want to know what A, B, and C is going to be. Now, to me, it only goes up, down, down, up. The period of the graph is going to be 360 because you can see a full cycle fits in 360. What's the amplitude and range going to be? So amplitude is going to be a half. It's basically the number in front. And range is going to be, y is going to be between a half, sorry, minus a half and a half. So you can kind of see how it lives between here. That's it. Okay, let's do one more and then we'll finish off for today. What is A B, and C for this graph? What is A, B, and C for this graph? Super Cicle, you are on the money. So it's not, well, okay, watch out. Because of this 2 in front here, the period of this graph is going to be 360 divided by 2, which is 180. So the first one here is 180. Your amplitude, you're quite correct, is going to be 3. Now, what's the range going to be? What's the range going to be for this function? Y equals -3 sine 2 theta. And then we're going to finish off for today. Final question of the day. Who wants to shine brightly?
Come on, guys, give us your best shot. Last push for the day.
All right. So basically, the lowest point it's going to get to is -3, and the highest point it's going to get to is 3. Okay. Well done, Super Cicle. I see that you are in the thing, Bonolo, and you're there too, which is awesome. Before we end today, I just wanted to ask, do you guys know how to use your calculator to help you with trig graphs? Give me a thumbs up if you know how to use your calculator with trig graphs. Give me a thumbs down if you don't. It's not always that helpful, but it is something which I can show you if there is a demand. Okay. Could we use what's called the table function? No, Awami doesn't. Okay. Because it might be useful for me at the beginning of the next lesson just to show you how that bit of your calculator works. And sometimes it's helpful for just checking things. I don't use it as sort of the first way of doing it, but it's helpful for checking. Okay. And then, Label, could you put the quiz, not the quiz, the poll link out to the students? Okay, so Nele and Awami. Okay, so I will, I'll try and get my emulator working, and I can show you kind of how a calculator can sometimes be helpful. And so, yeah, I think you would appreciate that.